Hi class, let's take a look at problem 3. Now, problem 3, we're going to have the same scenario as the previous problems. We have a function and then they're asking us to evaluate the area under the curve. So automatically the integral 1 over x is going to be equal to the ln of x, and the limits of integration are going to be 1 to 2. So at this point, let's evaluate the integral. So this is going to be the ln of 2 minus the ln of 1. Automatically the ln of 1 is 0. So this term technically cancels out. And we're simply left with the values of the ln of 2. So this one happens to be the ln of 2 as an approximate value. Let me check it. We're looking at approximately 0.6931. And I'll just say that the total area under the function in this case for f of x equal to 1 over x from x is equal to 1 to x is equal to the values of 2. It's technically the ln of 2, which happens to equal 0.6931, and then once again, units technically squared. And that's actually it for this problem. Let's take a look at problem 4. And problem 4 is going to be tricky. Now, let me actually go back to the formulas. And here's the basic idea on the integrals. If you're technically evaluating a integral and we happen to have limits, what the formula is going to do is it's going to treat this as a positive value, and technically this value, because it's under the curve, as a technically negative value. So for instance, this one, problem 4 has a little bit of symmetry, and due to the symmetry, it's expected that we recognize that the values are going to cancel out. So for instance, in this case, as we evaluate the area, we're looking at x squared divided by 2 minus x evaluated from 0 to 2. Let me put brackets to emphasize we're evaluating the upper limit. So this is going to be 2 to the second divided by 2 minus technically 2 minus, and then we're going to evaluate 0. So 0 to the second divided by 2 minus 0. This one ends up being, well, the second term, it's going to cancel out. So this one is going to go directly to 0. And then the first one, we're going to get 4 divided by 2 minus 2. And in this case, this is going to be 2 minus 2, or automatically 0. Okay, so for this problem, the value of the integral happens to be 0. And in this case, well, technically the regions happen to be, we happen to have symmetry. And in this case, this value happens to be a positive area. It's seen as positive, and then technically this area, the formula sees it as negative. And I'll just say the area below the curve happens to be a negative value. Okay, so that's actually pretty much it for this one, that the actual integral already takes into account the area below the curve as negative. Now, for another problem, and we're talking about a completely different problem, they may want us to consider the following due to an application, meaning this, this portion up here Oh, sorry, it wasn't actually. So this portion up here as a positive value, meaning it's going to be an area 1 as a positive, and then also this one could be an area 2 as a positive value. Now, if that was the case for a separate problem, then we would be evaluating the following integral. In this case, we would evaluate, so if both areas are positive, I'll just write if then in that case, we would actually be evaluating, so total area would be the integral from 0 to 1 of x minus 1 dx, and technically 2 times that, which will give us, well, a positive value. So in this case, we would end up with 2 times x to the second divided by 2 minus x from 0 to 1. And in this case, we're looking at 2 times. This is going to be 1/2 minus 1. And then we would remove the lower limit. So in this case, this would say technically minus, and everything will cancel out on the next portion. And this would give us 2 times 1/2 minus 1 would be negative 1/2. And this will give us negative 1. But then the whole idea is that we're treating it as a positive value. So in this case, if they want us to see it as absolute value, we would be adding those two. And this would give us technically 1 unit squared. But as I mentioned, that would be for a completely different problem. In that case, they would be considering the area above the curve as positive, and then also considering the area below the curve as a positive quantity. So they would have asked us to technically break the integral into separate areas. For the given one, our actual answer is just what we had in the past, meaning that the actual total value of the integral cancels out. That's actually it for this problem.